Hello everyone, it is with great pleasure and joy that I present my research work with you called Physiologic-Based Adaptive Second Order Non-Singular Terminal Sliding Mode Lateral Control for Uncertain Autonomous Vehicle, realized at the Laboratory of Engineering Systems and Applications in National School of Applied Science, University Sidi Mohammed bin Abdillah, Fez, Morocco, and supervised by Professor Mehdi Mellouli, which I want to thank him the effort deployed to achieve this work. I want to thank also the organizing committee to have accepted my work and present it today. Without further ado, let's move on the plan of work. Firstly, we talk about the introduction of my work. Secondly, I present the problematic of my work. Thirdly, I talk about the proposed solutions. Fourthly, I talk about the simulation result, and the end conclude your work and perspective. Mobility and transport safety are being revolutionized by the mass production of self-driving cars. These vehicles have the ability to drive themselves without human intervention. To be able to drive alone, the vehicle must have a total or partial control with the ability to detect any kind of obstacles within sensor. Secondly, interpret information received via sensor to plan a good trajectory, and finally, control and command certain parameters to maintain all the vehicle of the chosen trajectory. Several techniques and algorithms are used for the control and the command, of which the lateral control is the subject of our study in this paper. We use the dynamic of bicycle model of autonomous vehicle as shown in figure 1 to illustrate the lateral behavior of our study system. It is defined as follows by these two equations dynamics. We can have the state representation of this system is x1 equal x1, the derivative of x1 equal x2, the derivative of x2 equal f1 xt plus function g1 times the control law. The derivative of x3 equal x4, and the derivative of x4 equal function f2 plus function j2 times the control law. This figure represents the bicycle model vehicle, where x1 represents the displacement lateral, x2 is the lateral speed, x3 represents the yaw angle, and x4 represents the angular speed. Problematic. During the control phase, the vehicle is distributed by external load disturbances that cause the system to deviate from the desired trajectory. We ask ourselves how we can eliminate this disturbance so that the vehicle follows and converges toward the desired trajectory. To proposed solutions to solve the problems raised, we proposed to use the sliding mode control precisely in new adaptive second order non-singular terminal sliding mode control combined with the TS fuzzy Tagi-Sakano fuzzy logic technique. We describe the algorithm as follows. We defined in first time the sliding surface. Here's the formula of the sliding surface. Secondly, we define the tracking order defined as x1. X1 is the lateral displacement minus the desired trajectory. Thirdly, we define the Lyapunov function to guarantee the stability of the system, defined by this formula. And the last, we define the control law defined by this formula, where J is a function and alpha it is control gain determined by using the technique of fuzzy logic technique. Simulation result. We get the following result after simulations. From the figure 3 represent the vehicle trajectory within adaptive second order terminal sliding, lateral control, fuzzy logic, and fuzzy logic. The figure 3 represents the tracking error. From the figure 2, we can observe that the trajectory of the vehicle for the adaptive second order terminal sliding mode control fuzzy logic is driving towards the reference more quickly and precisely. The two trajectories are almost similar with an error that tends to 0. This is confirmed by the figure 3, which shows the error between the output and the desired output. Figure 4 represents the control laws generated, and figure 5 represents the behavior of alpha determined by using the fuzzy logic technique. Figure 5 from figure 4 and figure 5 prove the efficiency and the robustness of the algorithm developed for the control of our system. Figure 5 shows the behavior of a certain known positive constant alpha and his approximation obtained within the fuzzy logic algorithm, and we can see that alpha approximate tends to alpha. Figure 4 shows the control laws obtained by using the adaptive second order terminal sliding control and adaptive second order terminal sliding control using fuzzy logic technique, and we notice that they are merged with prove the efficiency of approach. Conclusion and perspective. For this work, we combined the TS fuzzy logic algorithm with the adaptive second order terminal sliding mode control for controlling an autonomous vehicle bicycle model and to estimate a control gain. Result obtained have demonstrated the effectiveness of our proposed algorithm for the tracking trajectory, but also the control law. For the perspective, we planify to design a control structure for our future work based on adaptive fast terminal sliding mode control with a TS fuzzy logic algorithm for modeling and controlling an autonomous vehicle. And thank you for your attention.